Welcome to First Line Technologies ConnectNext sessions. We are doing this on a regular basis throughout 2021. We've done a couple of them before where we're connecting with the end users, the community just like you, and allowing you to hear from experts. Sometimes you'll hear from Corey and myself about products that we're developing. Sometimes you'll hear from other experts within the CBRN industry or even within the AMBU response or EMS community that could talk about how they're utilizing a number of different products, not only within the first line bubble of products, but outside, and bringing knowledge that they bring from the operator level and the science level to you guys. This has been ongoing. Recently, we had just done a ConnectNext with Corey and myself. Let me reintroduce myself. If you don't know me, I'm Amit Kapoor, President and CEO of First Line Technology. Corey, you want to introduce yourself?
Yeah, I'm Corey Collings. I do training, research, and development here at First Line.
And today we had the privilege, and it's taken me some time to get her to come on board and discuss something that is very dear to me and dear to the end user community about SOP of Decon. First Line Technology has built a number of different Decon technologies using licensing of technologies from government labs and university labs. We brought these to the table for the end users to put together. We partnered with Emergent Biosolutions on bringing RSDL out to the community as well. But these technologies are just independent. And is there a way that an SOP can be developed that allows the community to use this on skin, surfaces, and across the board? So we got the honor today of having Christina speak to us. And she has a brief that she's going to speak about. And at the end of this, we'll have the opportunity to ask questions and drill her with some questions that she can give some great answers. And Corey here will be being able to read some of the questions and then bring them to the table with Christina. So Christina, thank you for joining us today. I appreciate it, again, and we look forward to this.
Thank you for having me, Amit. It's always great to work with you guys at First Line. As you know, it's been many years since we first met when you were licensing the first one of the Decon technologies that we developed at TSBIG, so Technical Support Working Group as part of DoD. And I'm going to talk a little bit about that one today. But what I really want to talk about and focus in on is the modernization of decontamination tactics, because we have seen over the past 10 years more changes in Decon than we've seen in the last 100. And so it's a time where things are changing. The science is coming to fruition, and we actually have data to go back and see what we're doing. So one of the questions that I always ask people is, why are you doing it that way? And my answer for people is, if your answer is because that's the way we've always done it, then really it's time to rethink why you're doing it that way and start focusing in on all of the information we know today that we didn't know back when we started doing Decon. So I'm going to go through just a little bit behind the process that I like to follow and the thinking that I followed coming up in the hybrid Decon approaches. So first off, we have to start out with, what is decontamination? So we have to remember that decontamination is the physical or chemical process of reducing, not completely removing, and preventing the spread of effects. So when we look at this, a lot of people have the misperception that decon and cleaning are the same thing, but they're two very different things. On scene, we're looking at decontamination and reducing the overall level of contamination as low as we possibly can, and then going forward and following up with cleaning and showering and other things. So when we start looking at this, we know today that just removal of the outer layer of garments, not everything, so we don't have to go down to skin anymore, but removing that outer layer is going to reduce our contamination level by upwards of 90%. So now we're only dealing with that 10% of threat material that might still be with us. And then we have multiple options for how we deal with that. We can actually just use an air-based approach, so a completely dry. We can use washing down with a fire hose, so a water-based approach. There's people who use emergency showers, including a water and soap-based approach. but there's many different ways to do it and combinations thereof. But we have to remember that decontamination must always be followed by cleaning. And that goes for people, PPE, and equipment. So some of the key considerations that I always look at when determining what's the best path forward are what was the state of the exposure? So what the contaminant that we're looking at, was it a solid? Was it a liquid or an aerosol? I treat them the same. And was it a gas or a vapor? And I treat those two the same. And did it get on a person? And if so, what part of the person? Or was it the whole body? Or was it just an object that was affected? And then what's the porosity of that object? Also, what's the value of it? Is the object worth the work and time to decontaminate? Or is it something we can easily replace and is cheap enough for us to do so? And then what do we have available right here, right now? So we have air always available. Increased air ventilation is often available with our positive pressure ventilation fans. Water, if we're there, we probably have water of some sort. Detergent. Sometimes we have materials that need vegetable oil. Okay, vacuums, and then absorbent materials. If we don't have some of these specialty designed absorbent materials, what do we have? Do we have dirt? Do we have a t-shirt? Do we have all kinds of materials that are out there today that, while it may not be the best thing, is it a suitable thing? And that's two very different approaches, right? And so then we have to also consider object decon. But with object decon, we can start looking at different solvents. We can start oxidizing and reducing things. We can neutralize acids and bases, things that we can't do if it's a person or a person in their PPE in many cases, because we don't want to increase the temperature inside that suit. To actually focus in on decon, you have to first understand skin. And so when we look at chemical interactions with skin, we're looking at these uppermost layers of the stratum corneum. And we're looking at the speed at which materials get on the skin, in the skin, and through the skin. So when the material gets on the skin, we want to look at, are there ways that we can get it off of the skin without pushing it through the skin? Okay. Then we have material that gets into the skin, and we have to figure out, can we pull it from the skin? Or are we pushing it through the skin? And then those things that already made it through, that's a medical countermeasure. That's nothing that we can do with decon to solve that situation. But as we look at different chemicals that we come across, we need to say, are those things water soluble or oil soluble? So are they going to go into the sweat areas of my skin and the proteins, or are they going to go into the fatty areas of my skin? Are they going to be lipophilic? And so it's looking at the different chemicals and looking at their interactions at the skin level. And this is really important. So when we do our research on skin, we actually go forward and only remove the stratum corneum layers and focus in on that area of the body. Now we have to also remember that time is really important when it comes to decon. For many types of situations, and for really the last 30 years of what we've done in decon, we've always focused on getting to the scene and setting up these proper decon systems. Reality of the matter is, that's great for our equipment later. But if there was somebody that was exposed, there's no time for that. We know that by the time we remove that clothing, we only have so much time before it's counterproductive and doesn't really provide any benefit. We also know that most chemicals that interact with the skin do so in a time profile that we don't have time to wait and set up. So it's really important that we try to do things that we can do very quickly, very efficiently, and will provide us a huge portion of the decontamination that we can follow up with later with cleaning. So in this case, it's about immediately and time removal of your clothing. Okay, that outer layer of clothing we know is going to hold in a lot of the chemicals. And then it's about the way that we focus in and potentially, if necessary, spot clean certain areas. Now the decon strategies, and you notice I'm focusing mostly on people and skin and PPE today, because the decon strategies for those can change quite rapidly based upon what we're seeing for the material. So we have to look at physical removal processes. These are the things that we're doing on skin. We can wash things, we can absorb them, and we can absorb them. So it's 3 different methods that we use. Now, when we wash things, we have to be really careful here because we're solubilizing a lot of the chemicals and then diluting it and having it go farther across the skin. So now we have more surface area covered, and if we have increased its solubility into the fatty areas of the skin or into the lipid areas of the skin, now we're actually potentially getting a higher dose. So we have to really think twice before we go down that route of washing with detergent and water, even though that's the way we've always done it. The science shows that reality is, in many cases, it's a counterproductive methodology. In reality, it's non-polar chemicals that we're going to do that with, okay? So things like oily materials. Now, when we want to look at how these things work, it's really about seeing the micelle approach. So we have that non-polar hydrophobic and the polar hydrophilic ends of the micelle. And so this is a fancy way of saying soap, okay? And what we're doing is getting that material to absorb into the middle. And we're really trying to get it into a solution by surrounding it with these soap molecules. And we end up with the non-polar portion being inside that's holding in that non-polar oily based material. And then the portion that is water soluble, the polar area, is on the outside. And that's how we move things from one surface into another. And it really works out important for us that we are able to do that because it's about the only way we can get things to mix. The way that I like to explain this is if you have ever put a pan that you've just cooked on the stove with and you have some oil residue and you put that into a container of water, so you're going to wash the dishes, and you end up with this oily film across the top. The way you get rid and break through that oil film is to put a few drops of soap in, and it'll start to interact and it'll start to break that oil up and solubilize it into the water. So we have to remember that's good for some things, but not for all. In many cases, it will actually increase the rate at which things like organophosphates go through the skin. So if they're already in the skin, it might wash them through faster. So we have to be really careful about that type of approach. However, if we are going down that water issue, we need to make sure that we have water as a physical removal process. So when we think back to, again, the 80s, when we started doing decon in a hazmat approach, we always talked about the solution to pollution is dilution. Well, that is true if you drop the person who is exposed or contaminated into a pool of water, okay? It's not true in the way we're employing water as decon. We're employing water as decon as a physical removal process where we're shearing the material off of the skin or the surface of interest. So in order for that to occur, we have to have a flow rate of about 2 gallons per minute and 45 psi pressure to get this to work. Now, when you're doing any of these things, if you're talking about skin on a person, please go ahead and add sponges and soap to that person because just doing the water alone in a lot of these portable tents is not going to have the pressure and flow rate that you really need for physical removal. So you're going to have to add something else. That shower per individual should last about 90 seconds, and you should use a washcloth to try to improve that effectiveness of the decon. But all of those things, as we talk about it, think about the logistics burden that's building and building for you. So you now have portable showers that you have to have going at the flow rates of our home showers. You have the pressure from our home showers. You've added in washcloths. You've added in soap. Now we have to worry about people slipping and falling. And we also have to worry about the runoff because we're not actually neutralizing any of that material. We're actually just moving it. And so by moving it, we have to capture it or it's become an environmental concern and a secondary contamination concern. So over time, as we started to study that, we started to realize maybe this is not going to work for us. And in this case, I'm talking about us from a Department of Defense perspective. So we started really studying this more and more in the early 90s to find different solutions that could really help us reduce that logistics burden and provide the same level, if not better level, of decontamination to the person. So as we went forward, we found that there were a couple of other issues that we needed to address, and those were mainly in the cold weather protocols. So as we had people up in some of the mountain regions, so you can imagine some of our special forces teams are very much focused on mountain regions, and we had to worry about the decontamination using our original water-based approach, because we would end up having people, the ice forming on people and under people. And so as you're getting them decon, they're slipping and falling, but they're also having the risk of hypothermia. And all of these things combined came in and said, we can't continue to do this. We have to have a better solution that allows us to work with decon without having to use water, especially as it applied to some of our cold weather areas or some of our areas where we were resource limited. So if you think of any of our special forces types of areas, these folks are on their own without a logistics supply for up to 72 hours. And it was really about them that we started all of this research in the 90s. So we started looking in at things that work by absorption. So if you watch how absorption works, you're going to have a high surface area materials and you're going to get the molecules to stick to them. And so there's a lot of different materials that we've worked with for absorption, but one of the things that really comes to mind is the filters that we use for our breathing. So way back to the beginning, when we did respiratory protection for our military operators, they very much focused on carbon-based filters and activated carbon and its ability to absorb different chemicals and hold them in place so that they weren't a problem. So that became kind of the focus, and the focus was, can we look at materials that we use for adsorption and find out how can we use them in the field in a form factor that would allow us to have a much smaller logistics footprint. And that really brought us to things like Fuller's Earth. We started evaluating in 1930s, the activated carbons that we had been evaluating for many years as both a respiratory and as a chemical protective clothing material. So all of those things came into play. And then we also wanted to focus it on absorption. So the things that we can pull off of a surface, things that we can incorporate into another material. And so each of these players these effects came into the roles here, and we started trying to figure out how can we develop a capability for our defense personnel that will allow us to move forward with something with a lot less footprint. So as we got there, we started developing different wipes and things, and a couple of things that we noticed right away. When we are decontaminating people in PPE, we have to be really careful on the way that we describe the wiping process. And it came down to, with people in PPE, you must blot material, okay? You put the absorbent, whichever material we're using, up against, and you allow it to transfer naturally across into that surface. You do not apply pressure, because by applying that pressure, which a wiping process is generally at least 100 psi, pounds per square inch, you actually can push material into the skin or into interfaces. And so when we talk about that, we always talk about wiping being something that we do on equipment. Blotting is something that we do on people. So if the people are just in their skin or they're in their PPE, we need to make sure we blot, okay? And so always remember, blot people in PPE, you can wipe surfaces. And it's about what type of material you're up against. So when we blot, we need to have something that's highly absorbent. So in that case, there's been a lot of work done on standard materials that are commercially available. So wound dressings, microfibers, all of those things. Those are things you can grab off the shelf. Reality is, wound dressing depends, adult diapers, any of those types of things work fantastically. But from a DoD perspective, we needed something that we could have in flat packages, we could ship, we could have on shelf for long periods of time. And what was done was a product called Fibretech, and it came from Texas Tech University. Fabulous work that they were doing with us. And in that project, back in started in 2000, worked on the evaluation of 30 different available products to see which one would provide us the best bang for our buck. And that's where Fibretech came out of. But the process we used was remove the outer layer of clothing. So we're removing 90% of the contamination to begin with, blot up as much as we can without any external pressure or rubbing movement. And then after that, flip to another area of material, absorbent, and then lightly rub to try to get anything out of there. That's what we did for liquids. For gases and vapors, it was really just remove the outer layer of clothing, because the gas came on, the gas came off. So it worked out quite nicely. So I kind of wanted to just show you a couple of points in history. And reality is, it was back in 1931 that the government started evaluating Fuller's Earth and seeing if there were ways that we could incorporate Fuller's Earth into the decontamination of those first generation warfare agents. So the bloods, the blisters, the choking agents. And that approach was used pretty well up until the M291 kit came out in 1989. So you look at a 50 to 60 year time period where we didn't make any major changes in this approach. So Fuller's Earth was very messy. A lot of people didn't like that just because of the messiness of it. You could actually get it incorporated into wipes and stuff today, but we actually wanted to go a little further. So the M291 came out, and that was incorporated with, it had an amber guard resin in it, which was black. And so the good and bad of it is it left black parts all over your face, your skin, anywhere you wiped. The good of it is you actually knew where you'd wiped. The bad of it is you now had these particles everywhere. And so while that worked for the time being, we knew right away we still needed to keep researching and developing to find that next product. And that's really where the Texas Tech one in 2000 won the contract to build their material that was a highly absorbent material that was in the middle. They had put in impregnated with activated charcoal. So now you had a highly absorbent cotton on either side, and then this absorbent in the middle, and it was fantastic. So it really took us from Fuller's Earth, which we were using just as a powder and sprinkling it like baby powder on people, to the 291, where we now had black residue and particles everywhere, to the Fibretech, where we literally had a piece of cloth that had absorbent in the middle, but you never interacted with it. So you kind of blotted on the surface. It allowed the material to move pretty rapidly into the cotton, because the cotton is one of the most absorbent materials we have. And then it started to work also with the carbon. So now if we look at this in terms of how operations changed, in 1985 was when that's when hazmat teams first started becoming reality. 1983 was the Benicia, California incident, which caused the development of all of the NFPA standards in this approach. It's the same time that OSHA was developing the guidelines that we still follow today, HAZWOPER. But in 1985, the US EPA produced a Field Operating Procedures Manual, which was their number 7. That's still used today by many agencies. And that's the multi-pool method that we always used to use, where we would rinse somebody off and remove as much of the contaminant as possible. And then we'd give them a little bit of a scrub, and then we'd rinse them off. And we had this like 19-step process that many of us have dropped down to about 9 steps over the years. But that's 1985 science. And it was what we had then, and it worked. But now let's fast forward to the things that we've learned along the way. And it was in 1999 that the Special Forces community developed their first expedient personnel decon procedure. And that was the first time we actually went to what we today call hybrid decon. That was where they used absorbents to try to minimize material, If they had to, they would do a little bit of a rinse and a spot wash, but very much focused on an expedient method with a low logistics footprint. And that started in 1999 and followed forward to today, where they still use the Fibretech wipe as part of that and very much focused in on where we are. Now, that's not to be said that we've stopped. We're still continuing to do research every day to find out if there are absorbent materials that are going to beat that. We haven't gotten there today. There are different wipes where we've added alcohol solutions and things of that nature. Works great for wiping off sensitive equipment, not so much for skin because that's actually a dermal penetrator. It will actually help many chemicals get through the skin more. So as we start looking at these wipes, we look at them for different purposes in different applications, and each one of them has a role. But these are all what I consider some of the important points that we need to understand for the Decon history. And that brings me kind of to where I like to say is the best of both worlds, and that's the hybrid approach to Decon. So we're going to use some water-based Decon when we need it, and we're going to use a dry Decon, including some air use of Decon, because that allows us to really focus in on what is it that we need. So we have to ask ourselves, did a chemical exposure actually occur? If the answer is no or we don't know, no action might be necessary. If the answer is yes, and the way I always explain it is you usually see irritation, redness, dermatitis-like symptoms, or even pain with no outward coloring, then in that case, we need to move forward and do some type of approach. If the answer was no, we may just be increasing ventilation. Okay, and that's generally if they're coughing and wheezing, otherwise doing nothing. But any of these approaches is a Decon approach. But if we see that interaction with the skin, that's usually with some type of corrosive material, whether that be a caustic, an acid or a base, a reducer, an oxidizer, those are the types of materials that we're focusing on to actually go forward and do a focused Decon approach. And I like to call that focused Decon approach for people and PPE, blot, apply, remove. And so we're going to first blot any chemical. In many cases, this may be the only step you have to do. Okay, so if you see chemical that's there, apply your absorbent material and let it move the material using wicking and pulling it over to the absorbent. Okay, then if we do have that irritation, we're going to apply water, soap and water, or an appropriate decontaminant. I say appropriate decontamination. What I mean decontaminant is if it is a chemical warfare agent or a potential to be a chemical warfare agent, we're going to put some RSDL on that. Okay, and then we're going to go forward and then remove that. And the reason I say remove is if we have applied something like soap and water or RSDL, we need to wash that back off the skin afterwards to make sure that that residual contamination is not there to either, in the case of soap, reduce the pH of the outer surface of the skin, where we now can start having other issues, increase the pH of the outer layer of skin, because the soaps are generally a higher pH than your skin. Your skin pH is probably going to be around 5, whereas most of the soaps we work with are 8, 9, higher. And as your skin increases in pH, its permeability for many of the chemicals is going to increase as well. And so that becomes problematic. So we want to remove any residual soap. And if any of you have ever played around with RSDL yet, you know that you need to remove that as well as soon as it has done its job. Okay, so a few minutes after it's been applied, we need to get that back off there. Because if you haven't used it, it almost feels like petroleum jelly on your skin. And it actually is a very oily material that will cause other problems. So that's the way I look at it from a flow chart approach to a hybrid Decon. Look forward and see, is it interacting with the skin? And if so, blot, apply, remove. Okay. Another way to look at that is from a first in exposure type of thing. So the first unit in may not have all the capabilities of a hazmat team. They may be the first person there, and they see people that have been exposed in some way. So they're going to ask themselves first, are the victims coughing or wheezing? Are they exhibiting signs of some type of corrosive material? Are their eyes or skin burning? And then do they have an exposure, but they don't have any obvious symptomology? Then they're also going to ask themselves, is the chemical that they're dealing with, and that's going to be from interviews or different information about the scene, was it a gas or a vapor, a liquid aerosol, or a solid? And each of those is going to bring you to those same answers. So for instance, if I had a victim that was coughing or wheezing only, and it was a gas phase exposure, like say ammonia, I'm going to move them to fresh air and enhance ventilation with the fan if I have it. Okay, that is going to get the contamination off of them. If I put water on it and it was ammonia, I'm going to make that into ammonia hydroxide, and now it's going to stay at the skin level and become a liquid type exposure. So very different approach when it's the liquid. If I have a liquid approach and they're just coughing or wheezing, I'm going to remove the outer layer of clothing if they're showing any signs of the liquid on them. If they have any observable liquid, I'm going to use an absorbent material to try to pull that liquid away from them. And if there's irritation, I'll go ahead and spot wash it. But if there's not, I'm going to leave well enough alone. When we have a solid, it's a little bit different. And the reason behind that is if they're coughing and wheezing because of a solid, I want to keep that solid from going airborne. So what I'm going to do is I'm going to provide some type of mist. That could be as simple as a fog nozzle up in the air above their head and let the water come down. Some type of misting, not direct spray. Direct spray is going to dislodge particles and send them flying. A mist is going to allow us to have the water fall onto the particles, hold them against their clothing, and then remove the outer layer. Okay, so minimizing the capability of it to become more of a coughing and wheezing hazard. When we get to those caustics and it's a gas phase, if we don't see any interaction with the skin, we might be able to get away with advanced ventilation with the fan and specific focusing into very small areas of the skin. If it's a liquid caustic and they have actually got a large portion of their body covered, you want to make sure any obvious material is blotted as soon as possible, because we don't want to put water on it and then spread the burns, right? We want to blot what we can, and then we're going to flush with copious amounts of water, starting above the head, moving down. This is where you need to remember your, heads, something, knees and toes, okay? Head, shoulders, knees and toes. Just remember heads, face, hands, shoulders, knees, toes, okay? So you got to get the head, then the face, shoulders and hands, then knees and toes. The reason behind that is we want to make sure it's always moving away from our eyes, away from our head, areas where we might be more susceptible for some permeation or penetration through different parts of the body. So we're going to go ahead, do an initial flush, then remove the outer layer of clothing. The reason behind that is if the burning was already occurring on the skin, the outer layer of clothing may be attached to the burn of the skin. And we want to make sure that we're not pulling and making the damage worse, okay? And then we're going to continue flushing as long as we can, always flushing away from the eyes. So similar types of approaches, but again, follows the same way. One's a flowchart approach, one's just a table. The real end result is if there's a chemical, blot the chemical first. Okay, any type of chemical. If you see a liquid chemical or any type of aerosol or vapor, go ahead and blot. If you see any exhibiting signs of skin irritation in any way, focus right in to where the irritation is, trying to minimize spreading that irritation further. Apply whatever decon you're going to do. When you're talking about a person, it's only going to be water, soap and water, and potentially RSDL. If you're talking about PPE, it can be other things as well, right? But we're going to apply that, and we're going to make sure that we do not wipe things into areas like zippers, interfaces, seams, those areas of PPE that are most likely to be breached if something were to go wrong. Okay, and then we're going to follow that up with a removal step where if it's the human skin, we're going to get that soap off of them to get their pH back down to where it belongs. We're going to remove the RSDL if we used it. And if we're talking about PPE, we're going to give a good rinse down of the material that we used, or at least some type of blotting of that material off of the interfaces where you're going to come out of the soup. And so as we look at that, the whole thing we want to everybody to remember is it's about blot, apply, remove, and using your options that you have available to you, modernizing your decon processes, and remembering that we can all work together to raise the bar. It's about making sure we work together using the science we have to modernize the way we do decontamination. Thanks, Amit.
So, Christina, very much appreciate you taking the time and educating us on the process, just starting off the process with Decon, looking at the whole process of raising the bar, the blot, apply, remove. It's really changing the paradigm. And just going back to what we've known for a long time that you talked about in previous SOCOM kits and SOCOM development. But this knowledge is so key for our first responder community and the military community to really just go back and just take a look at how they've been really doing decontamination. And very much appreciate the information that you've passed along across the board to everybody who's paying attention and listening on to this great presentation today. I appreciate it. So we have a number of questions. Corey's gonna read these off and then you know, get you on the spot to answer these questions and see what we can talk about.
Yeah, so just some real quick housekeeping things first. So we've had people registering up to and during this. So if anyone missed out for some technical difficulties or registered late, we are going to send a link out to everyone that's registered that will have this this entire video, including the Q&A, available. Because I get to choose the questions, I'll ask one of my own first. I wanted to see your thoughts on what really spurred this change in Decon over the last 10 to 20 years versus the previous 100.
So that's actually a great question. And what I feel actually instigated that whole change is prior to about 15, not even 15 years ago, almost all of our toxicology data on chemical exposures was for long-term exposures, many hours to many days. So if you go back and start looking at the toxicology data and finding out whether something's a dermal hazard, then you really are going back and looking at data of like a rat that was exposed for 24 hours. Well, if we're exposed for 24 hours, we got bigger problems here. So about 15 years ago, we made a big push to change the way that we do skin permeability studies and try to focus in on the use of human skin, freshly excised. We can't do it on the person while they're alive, even if they're prisoners. We're just not allowed to do that. So freshly excised skin, we generally get it from tummy tucks, breast reductions, those types of things, and then study it in the profile in which an exposure occurs. So look at the effects of elevated temperatures, elevated humidities, look at the effects of washing in using water if you don't do that blot first. And that's what really changed the way we do business is we now understand in a time profile that's relevant to us that these things are occurring and how can we make changes that will affect us in a positive way and what things will affect us in a negative way.
Great. So we have another question. Can applying Decon to the outer layer of clothing or PPE push contamination through that layer quicker as it does when applying to the skin? The example given is organophosphates.
Okay, so organophosphates we have problems with. Part of that is historically we've always talked about using soap and water as a decon. For many organophosphates, that can actually help it go through the skin. And so it's trying to figure out how do you minimize that. Now, if we're talking about a person who is in personal protective equipment, if that personal protective equipment is certified to the NFPA standards, then I would not expect the washing of the gear to push anything through the seams and interfaces. Now, wearing gear that is not certified to the NFPA standards, big different story. A lot of these, as you know, there are no zippers on the market today that are both gas and vapor and liquid tight. That's why we have all of those cross covers that we put the flaps that are protective over the zippers, because we don't have anything that's going to stop that from occurring. So when you add soap to your water, you decrease the surface tension of the liquid, and it'll actually start making its way around interfaces and through seams and any gaps much easier. So it's really about making sure that you're procuring gear with the integrity that you need versus just buying whatever's available or cheapest. And there's a reason why certain gear doesn't meet the standards, and it's all about seams and interfaces. And that's why we really push for people to buy gear that's certified.
Yep. Yeah, and I think you've mentioned, some others have mentioned that just making sure that your gear not only matches with the threats you're facing, but your gear also matches with the decon process you're using.
Yes, and so for the NFPA process, we did get added in a variety of the different decon solutions people use, and the gear is challenged with those to make sure that in addition to the chemicals that we are commonly coming into contact with, we also have these shower tests where the water comes from all different directions to make sure that the seams and interfaces are working well, and that water has a surfactant in it to make sure that it'll find its way around. And then also adding in things like sodium hydroxide solutions or hypochlorite solutions to make sure that if somebody is doing a reaction on gear, that is also taken into consideration.
So we've got one just come in. When comparing 90 seconds of wet decon to blotting, what do you think the average time is involved in blotting and then getting the patient to higher medical care?
Well, reality is blotting is much faster because you're still having to do blotting whether you're doing that rinsing with water or not, because that blotting is going to remove the most amount of liquid. The reality is, if there is something evident on the skin, the last thing we want to do is really spread it, the area that it's covering, right? Because now we have more capability for it to get through because it's covering a bigger surface area. So we still want to blot regardless of whether we're going to do that showering. So you still need to remove that first material. So reality is you're going to move them a lot faster if you're just doing the blotting and spot washing versus getting them through an entire shower system. I think our original estimates when we started looking at this was we had almost a 70% reduction in our logistics footprint and time on scene based upon mass scale decon. That was using
here's a question.
DSCL's software.
Yeah, here's a question that leads into that is, you mentioned that decontamination residue becomes an environmental issue after decon. And so this question's asking about, does this not lead to the delay in starting decon while waiting to establish holding tanks for runoff? Basically that issue of containing effluent sometimes is more challenging than the decon process itself.
And reality is we need to start deconning the minute the first unit arrives. We're not waiting for a hazmat team to get there if there's an individual with chemical on their skin. Now, if we are going to do a planned entry into an area of contamination, that's different. We can set up decon and things that will allow us to gather and save any of that effluent. But if we're doing a decon on somebody who has an exposure to their skin, there is no waiting and there is no worrying about the environment. We need to get it off their skin as soon as possible. And if that team is not hazmat ready, then anything that they have that's absorbent can be used, whether that be a cotton t-shirt or anything. So for me, I would put forward having some of the wipes and things that are highly absorbent. onto any engine and be used for those first arriving. You see somebody with an acid on them, somebody who's been cleaning their driveway and gets that splash on their skin, absorb that up and rinse accordingly. But do not just try to rinse, if you can, without trying to get as much away, because you don't want to spread that burn if you can help it.
Yeah, I think that's a great point about emergency decon. You know, life safety trumps the environment, but even if we're in a situation like that, it's a lot easier to manage a solid waste stream, as you mentioned, than a liquid waste stream.
Most definitely.
I think one last question. What are your thoughts on tape stripping versus blotting for decontamination?
So tape stripping is a method we use in the laboratory for removing the outer layer of your skin. So when you do, if you remember back to the image I had put up of the skin and its multiple layers, the outermost layer of your skin is really made up of a lot of really dead skin cells and things. So does tape stripping greatly reduce the efficacy of your skin as a barrier material? Not likely, but can it? Yes. And so tape stripping for decon, not really something that I'm going to put my head behind unless you are already in the hospital setting. And it's specific to certain chemicals that you cannot put water or anything on. But yeah, tape stripping, because it can, when it removes that outer layer, and for those of you who are hairy, when you tape strip, you are now, I'm looking at Corey's arms going, that's gonna hurt. So when you actually put that tape there and pull those hair follicles out, you've now created another entry point. And so yes, we use it all the time for our research to see what gets into the skin and how far in it gets. But in the field, that's gonna hurt and potentially cause more permeation.
Well, thank you, Christina. I think we'll wrap the questions up. Any other ones that we get in, we'll send you just by email, and we'll send it out we'll send all these answers and everything out to everyone along with the video link. I just want to take the time again. Thank you so much. Also, we're going to continue these ConnectNext series where we're bringing in subject matter experts. You might see Dr. Baxter again. You might see some other chemists, some other folks.
She has no idea.
She has no idea yet.
Thanks, guys. Thanks for the warning.
To really give this background, the science-based approach to what we do, because it's so important to First Line as a company. And again, anyone watching this, if you have some question that you'd like to really go into a deep dive on, let us know. I promise you, we know someone who has probably written a PhD thesis or something similar on that topic, and we'll try to get them up and do something like this. So Amit, any final thoughts?
This has been excellent. This has been so great. And again, thank you, and hope to do this again. We're trying to get in person, but this is part of our ConnectNext series. And, we had Christina on today. Again, appreciate it. We've had a conversation about the EDS kit, and we're looking to get more of these conversations going. And we're doing different formats. We're doing a conversation, we're doing where Christina can present her the science-based approach that Corey was talking about, operational tools that are going to help out by delivering products, and then bringing in other SMEs and subject matter experts. And if anybody out in the community is watching this and wants to bring up their expertise to the table and join the conversation, we welcome that as well. So again, thank you. And thank you everybody for watching. We're going to have this recorded and posted for the future. You guys can use it as a great reference tool into the future. So look forward to the next one. Thank you.